Alright, so this, we're calling it kind of an optional summative, but for some of you it's not optional. Just keep that in mind that depending on what your scores were and what your homework check scores were, some of you may or may not be taking both of these sections. Alright, so the first question, you are going to determine all the zeros and include any multiplicity you see, and then describe the end behavior based on the lead term test. So this polynomial is already in what we call factored form. So when I look at the lead terms to all the factors, I can kind of figure that out. My pen will work. There we go. What the lead term would have been if I multiplied everything out. So negative, I don't know why I crossed that off. Negative 4x squared is a monomial, so that is a lead term. And then if you're multiplying that by the next lead term, which would be x but it's raised to the third power, so that's like times x to the third power, 1 is a coefficient. And then the final term there for that polynomial would be x to the first power, so just x. Or you could write to the first if you want. So multiplying all those beginning terms of each of the factors together, you get negative 4x to the 6th power. So we have like a cousin of a quadratic with a negative coefficient, so the ends are going to be doing this. Don't really care what happens in the middle right now, I just know that the ends are doing that. So the degree of this polynomial is the lead terms exponent, 6, and then the lead coefficient would be this coefficient right here that we calculated to be a negative 4. So I can quickly answer end behavior while we're here. On the left side of your function, it is going downwards, and on the right side of your function, it is also going downwards. So now let's talk about the zeros. So this factor of negative 4x squared, when you solve that factor, like set it equal to 0, you would get an answer of 0. So there is a 0 for the function at 0, but it shows up twice because of the second degree. So you're going to have to write down multiplicity 2 for my next factor, which is x minus 1. That gives you a 0 at positive 1 when you solve it, but it has the third power, right? So that's multiplicity 3. And then your final factor of x plus 7 would give you a 0 at negative 7. And it has multiplicity 1. You can write that down if you want, but for my students I don't require that. And so here it does give you a little heads up that you should try factoring this to find the real zeros. But before you do that, the number of possible real zeros could be anywhere up to 4. And then the number of possible turning points is 1 less than that, so a 3. So the number of possible real zeros is just whatever the degree is. And then the turning points would be the degree, but 1 less than that, so minus 1. Factored form, so it's going to require a little fancy factoring on your part. That is a trinomial, there's no common terms, so you would start by factoring x squareds for the beginning terms, part of the terms. And then multiplies to 32, I want my arches to add up to negative 12, so how about negative 8 and negative 4? Now, this wouldn't be good enough if this was your factorization. This one's kind of weird because this one here is going to trip some people up. But x squared minus 4, everyone should be able to tell that that's not fully factored. So keep factoring that into x plus 2 times x minus 2. Now, I would be okay if you guys didn't continue factoring x squared minus 8. However, some of you are very impressive with your factoring, so you would continue on, and you would apply the difference of squares pattern to the blue one there, which means you would do x plus the square root of 8, but remember the square root of 8 reduces to 2 squareds of 2, and then x minus the square root of 8, so x minus 2 squareds of 2. So this, of course, would be the fanciest answer you could give me. I like this fancy answer because when I go to come up with all the exact real zeros, I just think about setting each one of these equal to 0. So for this green part, you get positive 2 and negative 2. And then for the blue part, you get positive squareds of 2 and negative squareds of 2. 2 squareds of 2. Jeez, I can't talk. Alright. Let's continue on. Oh, this problem. So valiant effort on the last test for some of you, and some of you just kind of left it blank because you had no clue what you were trying to do here. You should tell from the look of the end behavior, since it's a cousin of the quadratic, this must be an even degree polynomial. That's important because when you're done with your answer, you should kind of double check that. And then are there any multiplicities? And then can you figure out where they are and why? You can tell me that. So anytime it bounces off of the axes, we're going to assume there's a multiplicity of 2. So like right here, which is at x equals 1, There's multiplicity 2. And the reason for that is because it bounces. I know that's not the official term, but that's what we say. I think Mrs. Hoffmeyer's class calls it kissing. Mine is bouncing off the x-axis. Alright, right here we have an x-intercept at -3, I think, and then 1, 2, 3, this one must be at 4. So these two green ones are just singular multiplicities. So when I go to write my factored form of my polynomial, I'll start with the setup, which is y equals, there's going to be some mysterious k value in front, and then all these factors. So x plus 3 would be the factor for x equals -3. And then x minus 1, but remember that one has a multiplicity of 2. And then x minus 4 for that last green one. So this is our setup, but we're not done because they did give you another clue. It says up here, well, what if x equals -2 and y equals 108? So now you go to your setup and you plug in those clues. So if y is 108, I still don't know k. I'm trying to find k. Here we go. Don't lose this squared term right here. That's what happened to a few of you last time. You kind of lost that squared part. All the x's are -2's. And then the rest of it was just from the original setup. Alright, there we go. So what I like to do, brain calculator, whatever, I encourage you to always check your work on your calculator when you're on a test, because it breaks my heart when you get something wrong because you have a little mental meltdown. Alright, let's see, that's a 1 times, that's -3 squared, so times 9, times -6, so that's -54. So this blue blob here is -54, right? So we're going to divide both sides by -54. Oh, jeez, what happened there? I was thinking about writing down k, and I wrote down k. Alright, try again, Abuza. So k times -54. We're dividing by -54. Jeepers creepers, I should have wrote smaller. Alright, this gives us a k value of -2. So now for my answer, I'm going to write that down right here. And then I'm going to go back to my setup and write all my factors. So we had, what, x plus 3, and then we had x minus 1 with a squared because of the multiplicity, and then an x minus 4. And you can hardly read my writing, so I apologize. That is, whew, that is your answer. Yuck, sorry. Alright, moving back to, this question. So I'm not actually going to do this one, and I think these data points are gone. I think we deleted these to make the problem a little different than a previous problem we saw. So what you're going to have to do is enter this data into list 1 and list 2, get your calculator set up properly. When you look at your scatter plot, it looks something like this. So use a power function. So you're going to use, when you go to calculate, the one that says PWR, power of regression, make sure you're using that one. And that's in the calc menu of the stat menu. And then predict the braking distance when it's going at 80 miles per hour. So once you get your equation, you're going to store your equation and then figure out what happens when x equals 80. You guys actually did a really good job on that question, with the exception of those of you who left it blank. Alright, so the next section, this is also another old one, and some of you left this one blank, and some of you did a really great job on this, so just continue to do a really great job. 4x to the third plus 3x squared minus 5x plus 3 is being divided by, I like to put the divisor in parentheses, so x squared plus 2x minus 5. Now those of you who attempted the question and still had a little bit of a misconception, it happened on the subtraction step. So first step is to divide your lead terms. 4x to the third divided by x squared is 4x. And then you did a great job of multiplying the 4x into the divisor. So that is 4x to the third, plus 8x squared minus 20x. This is where some of you had a problem. And I always suggest you guys do this step in another colored pen, so you can kind of break up your work a little easier, but also you can really say to yourself, I'm subtracting. Some of you don't do the parentheses because you just assume that you're going to remember you're subtracting. Turns out No, you don't. All right, so lead term cancels. 3 minus 8 is negative 5x squared. Negative 5 minus negative 20 is a plus 15x. And then you're going to bring down your next term of plus 3. And then you start all over again with this new problem. So negative 5x squared now is being divided by x squared. And you get a negative 5. This is going to be our last step in long division. That's what's nice about having a large divisor, is you don't really have to do much work. All right, negative 5 being multiplied in now. So we get negative 5x squared minus 10x plus 25. Again, I suggest you use a colored pen to do this part. Subtract all of that, break up your work. Lead terms should cancel, they do. 15 minus negative 10 is a 25x, and then 3 minus 25 is negative 22. So, I have a mistake on my key. What a surprise. Alright, so this right here is our remainder, which means my quotient of 4x minus 5, and then plus the remainder, which is 25x minus 22, is still being divided by x squared plus 2x minus 5. There we go. Nice job, everybody, on the last test. I do want to stress, I think some of you who left it blank, like in theory, would not have left it blank, because I think some of you left it blank because you ran out of time. Now that's a whole other situation. That's you need to get better prepared for your test, but let this be your chance to shine. Alright, we are now synthetically dividing. Most common mistake on this question was a child who did not recognize that they were missing a term right here. There were a linear term that were missing, 0x. So when you set up your synthetic division, you guys did a great job with, the solution to the divisor, so negative 5, and then your coefficients are 2, 4, and then a 0, and a negative 53. Okay, so start with 2, bringing down the 2, and then it's a series of multiplies and adds. So let's see, that's a negative 10, which gives me negative 6. Multiplying those, you get 30. Remember, we're adding these up here. So 30. And then 30 times negative 5 is negative 150. Adding those up, you get, what, negative 203? So this last number that you get is your remainder. And when I ask for the quotient through long division or synthetic division, I expect the entire quotient with the remainder part as well. So this is the lead term for your quotient. So 2x to the third divided by x would be 2x squared minus 6x plus 30. And then instead of saying plus negative, I'll just say subtract 203, which is still being divided by x plus 5. Kind of crossed off half the divisor, but yeah, it's x plus 5. Get crazy. Oops, that's not an eraser. There we go. X plus 5. Alright. And then this question. Now, this one went a lot better than I thought it would, but those of us who had some misses, the misses were pretty grand. And some of the misses were just sad, like for instance, when we go to multiply the conjugates together. We'll see what happened last time. Alright, so they give you a listing of zeros. You have one at negative 5, one at 4, and then they tell you this. You have a 0 at 11i, which means you also have a 0 at a negative 11i, because these always come in complex conjugate pairs. So the next thing we do is write them as factors. So x minus 5 is x plus 5 as a factor. Sorry, x equals negative 5 is x plus 5 as a factor. X equals 4 is x minus 4 as a factor. And I think some of you tried to jump to the end of this question without showing this, and then you got yourself in a little bit of trouble. So this is x minus 11i, and then x plus 11i. And you can't stop here because it does say you must have real coefficients. So you're going to have to multiply this blue stuff out. And when you have single complex terms like this, these true, pure imaginary numbers we call them, they're a lot easier to just manually FOIL. So x times x is x squared, and then plus 11ix, and then a minus 11ix will cancel, and then you have minus 11 times 11, so 121. I squared. But remember, I squared is really negative 1, so this factor becomes x squared plus 121. if you haven't caught on to the pattern on that one yet, guys, when you have complex conjugates multiply together and they're pure imaginary number conjugates, it turns into what we call the sum of two squares. So back in Algebra 2 when we always said, oh, you can't factor the sum of two squares, well, that wasn't really true. But there you go. So please, please, please get some 5s on these sections, guys. I'd like to retire these sections pretty soon. We have bigger fish to fry. We have a lot of good material coming up, and I just want to move on. All right, good luck.